Okay, I'm gonna solve the problem 13.5, which I put all the givens over here. We have the big spheres and the small spheres. What do we know is the mass of the sphere A is 0.26, as well as the mass of the sphere B. Then we know the small mass P, the radius, which is the distance between this both masses to the small mass B. Then we have this angle theta, which is the inverse sine of these 8/10, which is giving us a 53.1. And then we know the coefficient of the constants of gravitational force, which is 6.6673 times 10 to the negative 11. The formulas we're going to use are going to be Newton's second law and the law of gravitational law from Newton's as well. And for the part A, we need to find the magnitude of the acceleration. And to find the magnitude of the acceleration, we need to find this force A and force B. Using the gravitational formula, we have the force exerted on mass A due to mass B is equal to G times mass of A times mass of B over the radius, and this is equal to 6.673 times 10 to the negative 11 times the mass of A, 0.26, times the mass of P, 0.01, divided by the radio, which is equals to 0.01 meters. And this is going to give you equal to 1.73 for the force of A times 10 to the negative 11. Force of B is exactly equal, and it's going to be the G mass of V times M mass of B over the radius, and it's going to give you exactly the same answer as mass of B. Then using Newton's second law, we know that the summation of forces on x direction is going to be equal to 0, and this is the forces on x direction. We have this force over here and that force over there, which is equal to f of A times cosine of 180 degrees plus theta, plus the force of B times cosine of theta equals to 0, and this is going to be minus 1.038 times 10 to the negative 11 plus 1.038 times 10 to the negative 11 equals to 0, which for that we conclude that the acceleration on the axis S is equal to 0 due that f of A is equal to f of B. So the acceleration of x is 0. Now we have to find the part B. It says we need to find the component of the acceleration of y. So we need to use again Newton's second law. Forces on y equal to 0, and the forces of y, we have the force of G minus the force A sine of theta plus force on B sine of theta, and equals to 0. And for force of G, we get that this is going to be 3.46 times 10 to the negative 11 times sine of theta, which is 53.1 degrees, and the force of G is equal to 2.076 times 10 to the negative 11. And we know that acceleration on y is going to be the forces on G times the mass of P, over the mass of P, and this is equal to 2.1 times 10 to the negative 9 meters per second squared. But on the y direction, which is the negative direction, meaning is pointing downward. So the magnitude of the acceleration is going to be a x squared plus a y squared square root, which is equal to 2.1 times 10 to the negative 9 meters per second squared, pointing downward. And that's the answer to the problem. Thank you.